So, hello everyone. I guess you should hear us right now. Yeah, I see a little green frame. This is good. Welcome to the second meeting of our novel and great DC Build Network. I believe that many of you have been part of the kickoff meeting we had, I believe, 6 weeks ago. And we are here today at the private home of Harry Stokman, and we are lucky to have the opportunity to go around the house today and to see how, Harry, you managed to build up such a nice DC object here. And just that you know, we will do a first invitation round here. I see Professor Rick de Donker. Hello, Rick. Great to see you, and also some colleagues from our Living Lab Hub project at Aachen. A warm welcome here from the Netherlands. Yes, my name is Yannick Schöpper. I'm a research assistant at RWTH Aachen, and I'm here with a few colleagues from our Living Lab Hub project that we are doing in the context of the FEN, which stands for Flexible Electrical Networks Research Campus that we have in Aachen, covering all the social questions regarding different DC configurations. So we will now do a short round. Would continue here to my right.
Okay. Hi, I'm Wiebke. Hello everyone, I can see you. Hi. Yes, I'm a bachelor professional of electrical technology. And I will build the FEN tiny house, the electrical installation. I work at the FEN. Yes, I don't know what else, or I can go.
Yeah, hi, I'm Sarah. You maybe saw me the last time when we did the kick-off meeting. I'm a colleague of Yannick, and we are from the project A Living Lab Hub from the FEN Research Campus, Flexible Electrical Networks. And we are looking more on the transition side of DC and the socio-economic side. So, interesting to see these things there. And also, we are planning the DC tiny house to build up during the next year, hopefully.
Next, Wolfgang, then.
Yeah, my name is Wolfgang. I'm working as a professional at Siemens Energy, focusing also on DC solutions. But here today, I'm from the private side. So I'm planning to build a DC home as well, and I just opened a company which is DC Bus Energiehaus to frame this activity.
Yes, and I'm Harry, and welcome in my house to online join it. And I'm super happy that there is attention to the social aspects of the DC installations, because that is a high valuable topic for me, because this is a really big part of the use case. And I'm very proud that I have the opportunity to show my private life, in this case, how I live, how I work, and actually how nice it is to be in a DC home. And thank you for that, to be online.
Yeah. Just a quick note, we will record this meeting today, to be able to distribute it online also for those who cannot join this meeting today. I guess everyone is okay with that. I see no objection. Now would be the right moment to do that, but I do not see any hand raised here. So we will now start the tour, basically. We will take the camera with us, and of course, as you can imagine, we do not do this every day. So if there are any major technical obstacles and you face any problems, please write it in the chat or just unmute yourself and tell us. That would be very wonderful and helpful. And that's it. Any questions from the audience at this moment? I mean, what's also important to mention is that whenever you have any question, just unmute yourself and ask the question right away, so you don't have to wait for the end discussion. We will see how long the tour will take, but I believe that we will have like 10-15 minutes in the end where we come here together to discuss some questions.
That will be then 5 o'clock this evening, all right?
Yeah. Okay, let's see. We're quite curious what will follow now. Okay, so then Harry?
Yeah. Okay, now I will start the demonstration. But I want to first bring a few highlights to you to understand, and then when I explain things, that you have the right background to look to it. You know my story about, I don't know if you know that all, but I have this story about family A, B, and C. And for me, the family A are the family who do everything what the government want to do. They drive electric cars, they have sustainable houses, they are sailors, they have a sailing boat, because they have a little bit money, because they can be the early adopters. And the family B, if people know this, the family B are the ones with motorboats, and they are just the opposite of the energy transition, because they see it as a little bit woke, and they see it a little bit as, okay, not interesting, and we have other ways, and they like combustion engines, etc. And then you have the family C, who don't own a boat, but in the end of the day, they are the biggest part of the society. And I want to demonstrate a little bit this project, that family A project, is really an insane project. And actually, I call the family A, a little bit to say it unpolitely, the family asshole. Because they are doing the things right according to politics, but they start to polarize the society. And this project is really built for two perspectives, because I'm a family A, and I have a sailing boat, and I have a sustainable house, and I have zero energy. I have zero cost on energy itself, but the neighborhood, in my neighborhood, the houses are social housing, so I'm a very contrast environment. And for me, the purpose of this project is to demonstrate that we have to make the next step for houses to build nice communities. And the other important topic I will show today is that the houses are built according to standards from the 60s. That means the requirement we have today from the energy transition, and particularly if the trend is to go all electric, then the requirement for houses to build doesn't meet the requirement what we have today. So we need to skip 60, 70 years in time to build new regulation for houses, to do it in a more proper way. And that I will demonstrate in this house. So I will also be critical to the eco-structure, the ecosystem itself, because there is a lot of things that are misaligned, and I will demonstrate a lot of things that are missing in the requirement for, like the wiring rules, like how the house shall be built, how many sockets shall you have, what is about the meter enclosure, all these kind of things. I will explain. So we can start walking, I think. Is that
just maybe the microphone? There was a comment. Could you maybe just move it a little bit? Yeah, maybe that will help.
Is this better now?
No, it's not. I just need you.
Is my mic better?
Is it now better? I think there was a comment in the chat.
Is it close now? Is it okay? Because normally I talk a lot of nonsense, okay. But
okay, no,
okay.
But I think
sums up. Yeah.
Okay. Very
good. Very good. Then we try.
Okay. Now I will start with the most funny object in the house. That is, look here. You see here, and my kid toys. This is my car when I was still a kid. I still like things to be forever. So this is a beautiful Lotus. And what is interesting in a household, if you look today in a household, in the old days, from the 60s, we had, 9 lamps, we had a television, maybe we have some kitchen furniture, we have a washing machine, but that was all the electrical components. So you have a handful, 10, 20, 30 electrical components in the old days. And all the houses are still based on that principle. But if you look today in a house, you will see that you have probably 100 components, 150 components. In this house, I can tell you, I have 150 LED, 144 LED strings to do the lighting. I have a lot of IoT devices, a lot of smart devices. So I'm closely more to the 200 of 250. Technically, I have 250 IP addresses in the house just for managing the equipment. So that means the house is not anymore a meter enclosure and then you have the nice furniture and everything there. The house becomes actually a technical cabinet. and you try to make a living inside the technical space. And that is totally the mindset. So that will demonstrate. So one topic I see from the safety point of view is that today electronic equipment, converters, chargers are behind the curtain, under the couch, behind somewhere else to hide them because you don't want to see them. So the first thing that is missing in houses is technical spaces to put equipment. And normally the technical space we have in a household is just the meter enclosure. And that is not suitable because first of all the meter enclosure is too small. And if you want to put everything there, then the meter enclosure will always remain too small because we don't know what is the need for the next 30 years. So that means the meter enclosure need to grow. And so it is better to start thinking about multiple technical spaces in a household. And I can give you one small demonstration here. Here's the first technical space.
Oh, wow.
And this is the interesting part. So that means I have to explain. I have 6 of these compartments in my house. And every major room, like the bathroom, like the entrance, like the media corner, have these technical spaces. And what is interesting in these technical spaces is that, and that is one of the interesting use cases for DC, because you can centralize the conversion. So if this is AC powered or DC powered, okay, maybe less important, but then you get a low voltage panel for a self, so like in this case 48 volt, and the 48 volt panel is really built for the local devices to power. And this is interesting because today, if you look back, you see here, for example, you have to follow me. You see here, for example, the USB-C. This USB-C socket is 240 watts. And this one is 100 watt, and this one is 15 watt, of even 20 watts. So this is high power. This is technically not possible to build inside the wall with an AC feeded circuit. So that means, because the adapter should be 350 watt, and you cannot build a 350 watt adapter inside the wall. The interesting part of it is if you did power this device with 48 volt, then you can build a 100 watt converter, and the 48 volt is directly connected to the PD 240, so you don't need a converter for that, and you have a very small converter for the old classic USB-A type things. And if you do that, that means you start to split your USB-C, to split between multiple of these devices. So you see many in the room. I have 12 of these sockets in my house, and they are split and they are powered here from the 48 volt, a centralized converter. And what is interesting about this centralized converter approach is that this converter is actually a fireproof converter. What I did to reduce the risk, I'm using these Meanwell. I will not make advertisement for Meanwell, but they are nice things. And they are normally the drivers that they use for street lighting. And they are molded. That means it's a very reliable way to build a converter, because if something fails in this converter, it will not create a fire. Because there is no air, there is no things, everything is closed, and that makes it possible. So I put these converters here, and then you will see there's a lot of lighting here. And one of the issues with lighting is, if you look to the fire department again, lighting becomes more and more dangerous. Because you get everywhere these small LEDs, you get these small drivers, and they need to be cheap, mostly AliExpress level equipment. And that means these are then put on the ceiling where you have your insulation, where you have everything. So you put these electronics in a very bad environment. So, and the nice thing about the use case, for example, to use PoE, and that has many people have overlooked that one, but we use here from microsense the drivers. But the interesting part for me about the microsense to PoE was that, okay, the losses from the PoE are in the switches, and the switches are inside the technical space, but the PoE drivers are incredibly high efficient from the light drivers. So I can use the PoE drivers. I have a couple of them on the ceiling, because they are 99 point something high efficiency, so they have a dissipation of 0.5 watt, and that's it. and I got a few of them here. And that means the use case here for the lighting is that if you're using PoE, and if in this case, in this house, is 144 LED channels, how do you use Zigbee, for example? Because today a lot of people using Zigbee, but you still need to have power. So it makes a lot of sense to, when you have these technical cabinets, to use PoE, because what I did here, you can see it here on the top. You see here a lot of tubes here coming in. So instead of normal houses, you have the centralized box in the ceiling and you go everywhere. But now I have route the pipes to a centralized point and I can change any cable in the pipe. So if I want to change the use case of a socket or a cable end, I can change. And this I can then mix, because this is important. This is one of the drawbacks we have today, because when we have our AC wiring in the tubing, we cannot easily put Ethernet cables in the same tube. So you need to have a separate. So you need to do using wireless in this case. And wireless is not that reliable, because if you're using Wi-Fi for your IoT, and next time Wi-Fi 4 is removed, Wi-Fi 5 becomes standard, Wi-Fi 6 comes standard, 8, 9. So you very fast start to aging, and you have this problem of security, because you start have old equipment still running in your system, and your house become, how to say, vulnerable. Nothing that there is nothing to steal here, but how to say, but that is the principle. And if you do wiring, power and data wired together, then you have a more solid connection to operate your system. So this is what you see here. So you see power over Ethernet switches. You see here the routing of the cables. All the cables are coming here from this room, coming inside in this cabinet. And then I have here 350 volt distribution. And this 350 volt distribution, then this is the pre-charger, because I have solid state protection in the house, because I don't want to have any other type of protection, because that is, to make it very clear, fuses and mechanical breakers are exit in DC. So solid state protection, the converters, and then I have my use cases wired here. And one of the aspects that this panel demonstrates, and that is the company who installed this, the worker who the installer itself was a very experienced person, and he has 35 years of experiences installing households. So he was know the details for houses. And the funny thing is that they work so much on habits, and they are used to work with a single voltage. That is one of the big challenges I saw from the installation perspective, because now the installer need to recognize 350 volt, need to recognize 48 volt, 24 volt, and even 12 volt. And then I have still a spare connection from the, how to say, the good old AC days. But there is there's no connection, no use case yet for that one. Now, of course, I have AC sockets. There is AC wiring anyway in the household, but that is there because when I always say when I go senile or I get a little bit, the kids throw me out of the house and put me in elderly care, and they decide to sell the house, then the house should be sellable. That is because it's still a big value. So that is what you see here. But here you see that one of the technical topics you have for the installer is installation coordination. Because you come to, so we change a little bit the wire colors to make it more simple. Because you see one of the habits is then when the installer have to learn, okay, when I see a blue and a red, that means 350 volt. Okay. Oh, I need to do work on that one. Okay, I go to the basement, I turn off the circuit and I start working on that one. But when the worker sees, for example, 48 volt or 24 volt, the habit of people is that you don't care about the installation. So you start immediately work on the circuit. And according to IEC, the colors for DC is normally when you have an IT network, a bipolar network, then it is red and white to use as the wire color. That means for 24 volt, that means for 48 volt, and that means for 350 volt normally. But we changed in current OS, one of the rules we changed is that in unipolar systems, we consider it the same as a three-phase AC system. You have a neutral and you have the three lines. And so we say when you are one conductor is earthed, that means, okay, that is a kind of neutral, and that's always blue. And that is very clear in AC, that you always have the blue as the neutral. So don't consider to in TN and have the earth terminal to be white, because that is confusing. That's why we introduced the blue, and this was incredibly helpful, because then the installer recognized what type of circuit you face in the household. And here, but one of the mistakes you often see here then, in this case, is that, yeah, you have these 3 voltages in one bar, and if you want to connect something, easily you make mistakes. So the equipment of failed equipment was relatively high during installation stage because of misconnections. Because lively they connect these things, so they expand, and this is one of the things we have to work out in the habits, and to bring clearness, and also to bring clearness, because these wires here are normally speaker cables. They use speaker cables, and they are normally 300 volt isolation classes, while these wires are 600 volt isolation classes. And of course, if you start to mix and if you start to work, you need to consider that this cable cannot be running against the terminals of a 350 volt equipment, because you have a risk for the insulation. So this is a lot of things that you learn. And the other thing is that we need, for the industry, we need to seduce the industry not to make industrial components for house, because this is now more an industrial installation than a household installation. But this is what I see on the mixture. So is this so far so clear? There are no questions about this topic?
Not at the moment, as I see it.
No, there's no question.
To the audience, do you have any questions? Not
No.
at the moment. Okay.
I have a question, Rick.
Yeah.
Did I understand that the USB-C or the lighting, the power supplies are completely in the technical cabinet, so to speak?
Yes.
And then they run to each, so you can control then the lights also digitally from a sample point or from an app or something.
Exactly, yes. That's what is interesting about PoE. That's why I moved the lights to PoE, because every drive, this is six channels, 2 times 6, so this 12 channels. They are powered by the PoE here, by the PoE switches, and this PoE switches. And the PoE is here, is 90 watt per channel. I can connect roughly, but you don't need that one, because most LEDs in this house are low power, or 6 watts, 3 watts, very, very small. And that is why you have this kind of centralized, but in the ceiling, there are a lot of also PoE drivers. You see here in the ceiling, you see, for example, these ones here, these lights are, the PoE drivers are on top. And these ones are by coincidence controlled from that point. And this one, these drivers are also, there are no drivers in these lamps, so there's only the LED that is here, and that one is then wired to the driver inside the control cabinet that is there. And then I can control with a current signal. I can control with the PoE. I can control with the TCP with the Ethernet protocol. I can control the current through the LED, and I can control my light. So I can make all this kind of atmosphere. And what I did also, maybe interesting to tell, is that in this house there is no controller, there is no EMS, there is no digital manager. There is only, how to say, I call it smartness. And that is one of the things I try to inspire the industry, because normally when you start to introduce an EMS, you want to have controllable equipment and you want to have stupid equipment, because you want to manage everything. And if you look to the real life, for me, that is a very bad approach, because as a manager, a good manager has to do nothing. Because if the manager is super good, he can sit on this chair with the legs on the table, and because if everything is running, he did a great job. A bad manager is the ones who do everything to control everything. There is zero trust, and you manage everything. You create a very bad atmosphere. Now, this same philosophy is there mostly from the EMS perspective. So you want to manage everything. So what the whole control system in this house is based on opposite. I only bring out demands, like a good manager does. He sits on his table, the feet on the table itself, and give them out. Okay, you have to do this, and he needs to trust that it is executed in the proper way. So, for example, the light system, again, are stupid devices and the drivers, but I modify a little bit the structure because I'm using MQTT for the light, and then I have the small light controller because it's still not integrated. But one of the big wishes for me is, for example, if Microsense says, okay, let's make this smartness inside our driver. So, and then I have a user interface that doesn't control. I'm using Home Assist not as a controller, but I use Home Assist as a demander. So the control system of the user interface gives the request and to say, okay, hey guys, in this room I like to have so much light. And which light should be reacted, he don't care. But then the lights itself should know, okay, that means this room. And you can make then interesting approaches, because if there are light sensors and the light says, okay, you want to have so much light, but sorry, the sun is shining, or I don't turn myself on. Or there's maybe nobody in the room. And you could say, okay, we can reduce. So you can bring this local smartness, edge control, instead of this globalized control through an EMS. So this is also the whole control scheme what I'm using in the house. So to make on the edge and then build the smartness on the edge, and then you don't go to big data, but you go to small data, because you don't need any more to manage. And this is also done from the cybersecurity point of view, because the more you compile your information, and the nice thing about, for example, is MQTT, that you publish information and you can subscribe to information. And the interesting part is that I make a unified interface for publishing and subscribers, so you can build still more and more smartness. For example, just to make a stupid example, if the light gives demand for so much lumen to have, and in the same time he subscribes, for example, to the battery. And if he sees that, and he subscribes maybe to the interlink converter, and he sees, hey, the interlink converter is going down. Okay, I know that my light is now coming from the battery. Oh, but hey, I see the battery going down. Maybe it makes sense that I start to be optimizing it, instead of to have a controller that makes these decisions. So you can bring all these kind of things, and that makes value for the manufacturers, because that I see is a big use case for manufacturers to move to DC, because you can build again smartness inside your product, and make the features you put in your product as a value. That's what we try to stimulate in Current OS, is that instead of making stupid converters, stupid LED drivers, make beautiful LED drivers, make beautiful converters with beautiful, nice features, and start to compete on functionality instead of price and stupidity. That is a little bit the goal what I try to stimulate here.
So
that
Harry, there's a question in the chat. Which type of UTP do you recommend?
UTP, I'm using TTs. You mean from Ethernet?
I don't know. Just ask Huub Noven.
The connectors. You mean for the Ethernet?
There's only UTP written here, so you have to ask the person what this question means. I don't know.
Can you explain a little bit what you're asking?
You can integrate home EMS with home automation, at-home security. What is your experience with this?
That is exactly
cable type.
I'm using Home Assist as an interface, only as interface. I can show you, please.
Yeah.
It is a little bit, I hope you can see it. I have panels, and I don't use any control. There's no automation inside this panel. So Home Assist, I don't use the rules for management, I don't use Red Note for controlling. It's only what this does is I put the sensors to connect to MQTT, and I put the controls to publish information. Nothing more, nothing less. And that means every room has a controller, so the bedroom has a controller, because there are no switches inside this room, because the switch is stupid, because the switch cannot create demand. It gives just only command to go on, nothing else, nothing less.
Yeah.
And this one gives the demand. So, and on this panel, all the sensors, I have subscribers, so I can read out a lot of information. So I have technical panels, and you can read out all the parameters. So there's a lot of information, and there's no control on the point. And I think that is a very important one, because I think it is a mistake from security point of view to assume that managers, EMSs like Homey or all these kind of things, does management everything, because you create huge vulnerability and you create huge complexity if you want to replace equipment.
Yeah.
Because now this system doesn't need to know what are the devices that are in the system. It doesn't matter, because he just gives the demand. So if you put additional equipment to the system, and this equipment is subscribing to demand, it can take its action. So you make it easily scalable for homeowners, because today the people who do home automation are the freaks, the nerds who positively way. I'm a nerd myself too. But you do it, then you make these complex things. But if you think about your grandmother, or you think about other people who are zero interest in automation, how do you deal with IoT equipment in a home like that? So how do you make it personal friendly, human friendly?
Yeah.
And one important aspect is I took into the control, I cancel out the human. Because in the end of the day, the human is the most horrible person in the system. If they are angry, they are very expensive. But if you look to energy management, you cannot depend on the human for energy management. Because you forgot, like the lights you forgot to turn off. So the system should be supportive. Yeah. And one of the demands of the control system is that you have to bring the comfort, and you bring the happiness to the environment. But technically, I know everything myself what we can do. But like I say, my mother, she can handle the iPhone. She can do some banking, and she can look to the email, and that's quite something for a mother of 87 years old can do. But I'm sure when she want to connect a light, and you have a home smart system, she will not manage. So again, it makes so much sense to disconnect this controllability from EMSs, from control from home automation, to bring it to the products, and the products can take the action, create on the demand. This is, I think, a very important topic to understand.
So then it's a kind of plug-in and play solution that works for everyone, and it makes this kind of control in a way flexible and updatable. Because that would be a problem maybe with the classical EMS system. If you change one component, then people would need to call for an electrician or something. Yeah.
Exactly. That is the point. So you have to start, when you move things into the electrical field, you have to start thinking about these aspects. And of course, if you want to look only to the business aspect, it's nice to sell EMS, because you sell dependency. And that means you can make a subscription, you can bring a service, you can bring additional business. But you start to, I think it's a negative approach. You should have a more friendly approach, that people are happy with your product, and they buy again a new product because they're happy with it, they like it, instead of they are forced it. Because you want to, like the Apple ecosystem, once you're in an Apple ecosystem, you buy everything for Apple because everything is interconnected. But it's much nicer from the human perspective, if it doesn't matter anymore, if it's
if you have a multi-vendor system.
A multi-vendor system. So you need to be independency, and you should not be linked to a structure that are forcing you. And then, of course, from the business perspective, it's super nice to make this lock-in.
Yes.
But from the user experiences, it's not nice to have this lock-in.
Yeah.
So you need to unify it. And that is one of the goals I try to demonstrate.
Definitely. There are two questions here in the chat. I would put the last question here first, because we are standing right next to the display. But I promise to you, Vasif, we will also ask your question then after that. So the Zoom user anonymously is asking, what will you do when this display device goes down?
Well, not a problem. I can, because that is the nice thing about if you have demand control, you can put the demand. You can put the demand everywhere.
Mm-hmm. Okay.
So
Yeah.
you don't. So there is not dependency on the display. If you have a controller,
Yeah.
as an example, and that is why I don't have a server on this platform. I have only. So the nice thing about it is a little bit technical, but you can MQTT is working with brokerages, and when you have a broker, you can install multiple brokers. So every device here is not only a small device that subscribes to things, but they also hosting a broker. So they are also becomes the backup automatically if one of the controllers is removed. So if you make this transparent, there is no client-server approach anymore in this system. So I have here every smart device is a broker and as part and helps to robustify the system. And if one broker goes out, for example, or then automatically the same work is still done by the other broker. So every controller is automatically redundant to make sure that the message. So that means I can easily use with the app on my phone. I can bring the same demand. So and I can and that is the interesting part because you can only bring demand, and if the demand is out of range, the equipment makes the decision not to respond. So if this system is hacked, for example, because somebody wants to do something ugly to me, okay, he can create some discomfort. But there is no, how to say, buttons to shut down the system. There is there is no, that is not there. It's only that they can say, no, okay, demand is, I want to have the lights off. Then my system can say, yeah, I see in person is this room. Sorry, it's dark. Sorry, you asked me to go down, but I make the decision just to be active. So
because it's then a form of distributed intelligence in the system and not one central intelligence that could be hacked in a way.
But could be controlled then. Because that is the risk if you do control outside your system or you do your control inside the cloud. That means people can take over the system. And in my case, they only can create a little bit discomfort, but they cannot take over the system. So from the philosophy, it's interesting. And what is also interesting is that you can, from the privacy point of view, you can control what you want to publish. Because you normally in digital networks where you control, all the information is on the system, and all the information comes to the centralized controller. And you need to have protection layers, everything. But I just publish the same as in the street. Okay, but, when I'm dancing on the street or walking on the street and I'm talking, okay, I only say things what I want to say, not to hurt people. How to say? So everything what is in my mind is not feasible to the outside. And that is the interesting part. So again, it is the philosophy how you manage, how you control, is an important one that you understand. And that is why in the current West principles, we try to use what we call the Dutch water system, the Dutch water management system. Because I can tell you, if you want to read nice stories, if you want to be trustful in a society, if you want to make these kind of things, you should read the Dutch water system, how the Dutch water system is working. Because it is the oldest system what we have on this planet. It is a 1,000-year-old system based on democracy, and it is based on resiliency. And the interesting part of it is that because in the Dutch water system we don't have centralized control. There is the government cannot manage the decisions in the local polders. We have a local community. We trust some person from democratic selection. We trust some person who makes the decision to do the water management. And we have our own budgets, we do our own maintenance. So if we make locally decision not to rise the dike, okay, then everybody understood, maybe not a good or smart idea, but because then you feel that you take risk, so you are willing to maintain it. And the interesting part of that one, it is not coordinated through the country. That means there is no program that you shall rise the dike, or there's no program that you should not do it, or whatever. And that means if somebody makes a mistake, the mistake remains local and not centralized. So, and that makes it incredibly robust. So living 6 meters below water, we are now 6 meters below water, is more comfortable and more safe than 10 meters above above the sea line, because there is no management, there is no system in place that ensures this high, and this philosophy from the Dutch water system is completely embedded into this system. So that means every part is like a small polder, a local area, managed itself, and there is no coordination, there is no centralized management, and that makes it incredibly flexible, incredibly resilient, and you can manage completely what you want, how you want to expose it, and that is the philosophy, and that also based with the current rest. That's why the droop, for example, the droop control, the voltage, because now today it's really all the time happy hour, because I'm running at the maximum voltage all the time. You see it's 380 volt, so sun is shining, we don't have enough loads, so everything is this continuous happy hour. So technically that's why, and to be honest, I'm now pushing back to the grid. And not that I intend to do that one, but I want to compensate my old meter. I have still a rotating meter. I want to compensate because of the building, the renovation was taking a lot of energy. The renovation consumed 10 megawatt hours, and I've measured that one, so I was so bad enough. So I was, because I really look at that is one of the things we have. There's a big low-hanging fruit for constructors, because they don't pay the energy bill, so they don't care. The lights they're using, the heaters they're using, the dehumidifiers they use, they don't care about the energy. So they have crappy stuff. They connect. They even the area where they have the small kitchen to sit and the toilet and all these kind of things. Now there's a resistive heating. In the weekend it remains on. They don't take care because they don't pay the bill. So again, on the working place where people do the construction, you can save a lot of energy by giving incentives or giving a structure to build. So that's why I was monitoring it, because I want to find out where are the spoiling points that could be avoided from the energy. And particular, if you think about a little bit philosophy and think about it, in the end of the day, it will be probably charged by batteries, because when you do construction, you start building houses, not always the energy connection is there. And if the installers have to go all electrical with all their equipment, okay, you want to make an energy efficient system again, because you want to save cost on your battery, and then the constructor is responsible for the energy. And this is a kind of, so I want to prepare this mindset a little bit in this way to the build.
Harry, just one coming from the more philosophical mindset questions to a hardcore technical one, which is this one here from Vasif Adnan. Does each technical cabinet have a dedicated MQTT broker, or do you have a single broker for the entire house?
No, I have here now I think 12 brokers.
Okay.
And they're all running in redundancy. And it is not in the technical cabinet. So the technical cabinet have zero intelligence. The technical cabinet is only there to provide a place for the equipment and provide the routing of the cables, the connection of the cables, and to provide the converters. So I have a couple of Raspberry Pis, very simple. Raspberry Pis that are combined with the equipment to build the smartness to make, because this equipment today you buy is not smart, it's stupid. But that's why I make a workaround to have dedicated Raspberry Pis with dedicated software to take over this smartness for these devices, to make it as if the light is the built-in smartness. So that, but every LED driver, for example, of Microsense has an MQTT broker. So that means I don't use them all, but then if I have, I think, 24 of these drivers, so I could extend with 24 more brokers. So then I have 36 brokers in my system. Now then you can lose, if you lose one, okay, there's zero outage risk. So you make it a little bit, in the case in this way, not dependent anymore. What is connected, what is missing, if one switch goes down, and by coincidence that switch contains the broker, okay, again you have a problem. So,
Yeah.
and in this case, every distributed in a home are all these controls. If the power go out in one section or whatever, no issue.
Yeah.
All the servers remain working, and that is the interesting approach. So that is a very resilient structure to make control, and this is what is pity, because nobody is doing it in this way. Everybody is as I to explain, everybody is operating from a business perspective, and the business perspective is management, and it's lock-in, it's control. You own everything. If you manage everything, you can make the decision, and you can force what equipment you shall buy or which manufacturer you shall use, because that fits in your system. So you become the power. And for me, how to say, if in particular in private space, you should have power to the people. Power to the user. So that means at least maybe my mind is working like this. I don't like have somebody else managing me. I'm already quite well managed by my wife and by my. But I don't need to be managed by a supplier. For sure not. And that is why I think that is important.
Yeah.
Is it so far clear?
Okay, Wim Schaper, I hope this also answers your question if the broker function is hosted on a Zigbee device, because no it's not. It's
I have Zigbee. I have Zigbee because I have a few drivers on Zigbee, but Zigbee I try to avoid as much as possible, because Zigbee for me is a demonstration of stupid devices that bring communication to a controller, and then you have the Zigbee device. Of course, the protocol to transport is a nice one, it's meshing, but the issue is that Zigbee is incredibly fast congested. And if you have like 144 lighting points that are controlled, you have 144 Zigbee points. And then you get this latency issue. And that is again, and how do you deal with protection? How do you do with safety? How do you do, because you need to update the firmware. And if you're using PoE in a physical wiring, you can bring them to a VLAN. And if you bring them in a VLAN, you can isolate on the communication network, you can build a protection. So you make the protection scheme on the physical wiring, not to have, because that is the disadvantage about wireless communication. That you have to bring the protection to the devices, because everything is accessible, and that's why, and you need power anyway to the devices, so you need to wire. So that and if you want to do everything with batteries, be my guest. I'm still capable to stand on the stair and to find the device with that battery, but again, from the human perspective, if I'm 80 years old and the battery of, for example, the light sensor is down, no light, I have to call my sons, and he's living now in Groningen, so it's 200 kilometers away from here. And hey Anthony, can you come to change the battery? And he says, can you come home? You use a candle in this case. So you need to think about these kind of things. That it should be, how to say, human friendly. It should be easy, and that's why if you have data, as long as it is feasible to wire things they need, then you should wire it. And most devices, particularly on the sensor part, you see the sensor here. For example, I have all these sensors here, and these sensors are measuring a lot of things, and they broadcast this information. So they broadcast every room. They broadcasting. The temperature, the light, the humidity, the air quality, the CO2, how many people are in the room. So they are smart sensors, but they publish this information. And then, the other equipment, other topics can subscribe on it and then with their smartness. And if you can make the relationship as for example, an EV charger can subscribe on the same way, and to see, now there's cooking, something happening, there's something happening, and I can take actions. Do I need to charge? And my agenda can push that information that I need so much range, and then the charger can say, let's see how I can charge, instead of control-driven systems, because then you get this headache, and then you get these huge control schemes like in RedNote or in maybe in scripting, and it becomes incredibly complex, incredibly vulnerable for mistakes, and incredibly buggy, and hard to manage.
Okay. Thumbs up by Wim. We go on.
Okay, yes.
Okay.
So the interesting part is that you see again on the screen, you see the state of charge of my car, and every device in this house, there is 0 cloud services, there is no anything from third party installed.
Yeah.
All the devices are inside this ecosystem. And so no different apps, no different.
And you're not dependent on the internet at all.
No.
Yeah. Okay.
And here you see the old meter enclosure. So I have the most classic meter enclosure you can still imagine. It's incredibly reduced.
Wow. Yeah.
Nice new one.
Yeah.
So I take an ABB, even that Schneider has made me happy. I have taken ABB panel. That's to demonstrate independence. And I have still an old AC connection for my car also, as I'm playing with this one. But I integrate, so I don't make my own, I make my own charger, not use a standard one. So I use the small controllers here. So again, here's an MQTT, here's everything there built in, and I can manage this one to the car on AC. The DC version is still coming. I'm working to have a semi-fast charging at home. I will have a 30 kilowatt charger on DC. And again, that will be, so how to say, put it simply, I've built a hobby for life. It makes it possible to make these edge controllers smarter and smarter and smarter in a way that you can make these things happy to integrate in the case. But this, I have still an old meter. This meter is soon illegal in the Netherlands. But I'm testing the grid operator how they will handle this meter, because there are so many meters still installed that should be replaced by a smart meter. And I'm a little bit testing that how they will manage this one, because the net metering will stop in 2027, and that means that you shall have a smart meter. But if the grid operator doesn't have time, no hands to install a smart meter, the net metering continue for these meters, because now it's spinning back, so it's counting back. So you have actually the way to compensate your summer energy with the winter, and that is what we did in the past in the Netherlands, but that is not anymore allowed to have. So it's a little bit playing around with the grid operators.
Your stream, new questions.
Okay. I can see now.
Wouldn't it mean for your home installation if the connection is a grid where DC instead of AC?
It will now put it this way. I'm happy with the AC connection. And because the infrastructure is there, and that is still the part of the biggest machine that mankind has ever built. So we need to endorse and we need to respect our AC system. But what I'm aiming for, and that I will demonstrate, that this building is an insane building from the energy point of view. It is for 2 person, it's stupid. And I want to build the energy community. I want to build a second grid. I want to support my neighborhood. Because you can see my car is a charger, I do everything for free. But the other side of the street is social housing. And that's the reason I see is a big use case for the second grid. It's a big use case is that you build an independent system for the community. On the same philosophy what is done in this house. So what I do here in my house, I want to do on a community level. And on the community level to build a microgrid that is supporting the AC system, but work as a standalone system. That's the reason why we call it second grid, because it's a second system in the neighborhood that can work independent, can work to support the AC system. It can be work as a kind of bi-direction, but it can also work really on the community level. And that is because in the end of the day, grid operators need to do something in the social domain, particularly in the Netherlands, because everybody's literally fucked up with the grid operators because of the issues they have today. So they need to make a charm offensive or a charm campaign.
And the issues are grid congestion and high grid fees, or what are the major obstacles here?
The major obstacles is the grid congestion, and to fix the grid congestion, you need massive investment, and this massive investment needs to increase incredibly your subscription. And the point here is that normally, if I have done everything on AC, then I should have in this house, I will be connecting then roughly 40 kilowatt of inverters to a 15 kVA connection. And normally this 15 kVA connection is planned, how to say, on a real continuous capacity of 3 to 4 kilowatt. So that means I start using it beyond the overbooking factor for the grid operator. So the grid operator need to expand. And the point is, if the other people don't do that, and they need to expand, and because of the subscription is socialized, my neighbors start to pay for the craziness I do in my house. So that is not correct. So for me, that's why power efficiency is more than energy efficiency, because if you can reduce the power to the grid, and that is one of the use cases for DC, because the interlink, what I always say, the interlink is the most beautiful device on the planet, because this device can manage the amount of power that you connect to the public part and how much pollution, how much demand you take from the public part. And technically I can connect this house to 1 kilowatt interlink converter. So technically the 3 times 25 amp I can replace with a single phase 4 amp, or with a 3 phase 2 amp, for example. I can make a very small connection that my household doesn't matter.
Okay. The next, come a new question. The Zoom user asks, I see problem of physical switch solved. Where do you draw power to run devices like TV unit?
Yeah.
For
Yes.
technically, this television, I don't do it, I've still powered on AC. But you see here a small subsidiary technical space. So I put a metal cabinet here, there for a little bit for the cooling properties to connect. And this is what I call my media corner. And I expect, I hope that the televisions in the nearby future get USB-C connections to power, because it's 240 watt. It's plenty enough for a 65-inch screen to power. Technically, I can connect it to 350 volt. Because I've noticed that most television are tolerating 350. So, not by the data sheet, but by trial and error.
Okay, yeah. But you have to be risk-taking then.
You're risk-taking. Yeah. And one to maybe also to little bit to inspire the equipment manufacturers. I got still my old speakers, 45 years old. Yes. I'm very dedicated to them because they sound so beautiful. It's old transmission lines speakers. But the interesting part of that one, that is one thing to consider. I expect that in houses you get a lot of distributed batteries. So it makes a lot of sense to have the amplifier battery powered, and then with a small USB-C socket to charge and to have high power for the beautiful basses and the beautiful sound. But so that means you will get to have more and more batteries that has double functions, because a centralized battery in a cabinet is only there for energy. Of power services, but if you distribute the battery, you get a second use of batteries, like in a small vacuum cleaner, or in the grass, our grass dog, our device that do the mowing. The mowing. These batteries have value there because they bring additional functionality. So the vacuum cleaner and the stereo equipment and maybe the induction stove are the perfect places to install batteries. Because where you need sometimes big power, but then you need low energy, then an induction stove is still power but low energy, because the energy consumption for a very big meal is 1 to 2, maybe 2 kilowatt hours. it's incredibly limited, but the power is massive. So it makes much more sense to distribute batteries to equipment, again, to build the smartness of a stove in a way that you distribute the batteries. And this gives a better business case also for battery, because you have a way that you replace equipment, you replace the battery, and you have a more, the same as your laptop, the same as your vacuum cleaner. When the battery is died, that equipment probably is end of life and you replace it. And if you have stationary batteries, like I also have here, then you don't have that case. But also for time, because I don't know.
Yes.
Now we come now in the area where I need to fix a lot of things still. The stairs is a Dutch stair, and it's steep.
Okay.
So hands on the rail.
Yeah.
And I make a nice, what is the line diagram.
Yeah.
And here I connect what is the interlink converter, the system, and there is my next step is here. You can see it's moving to the second grid, and this is the community connection where you start to make friends with your neighbors instead of polarizing with your neighbors. Because now I'm polarizing.
Yeah.
Because I behave asocial. And here you see also one interesting thing is that one thing I did there are 2 units of these. I did an insane amount of tubes in the floor. And I did that because I have 2 loops. I have one loop that is linked to PCMs. So in this floor I have 800 blocks of PCMs. And they can store 100 kilowatt hour of thermal energy. And the orange one are the storage loops, and the white one are the fine control loops. And what is interesting is that the temperature is completely stable in the house because there is circulation on the PCMs. So the temperature is all the time displaced through the whole house. So when the sun is shining in one direction, that energy moves to the colder part. So there is no topics here. But the advantage about doing this, because this is twice as much as tubes that you normally have in a household, that I can reduce the temperature for the hot water to heat. So on the moment, for the winter, I'm using 22 degrees of water temperature for the floor heating.
Oh, that's
incredibly low.
Yes.
Most houses using 30 degrees, 35 degrees.
Yeah.
And if you have a heat pump and you have to make 35 degrees, your efficiency will be much lower, much less. And okay, sorry. But take the hand on the rails, because
okay. After. Oh, it's really steep.
That's in Dutch, dit is Amsterdam stair.
Yeah.
So welcome in the technical space.
Yeah.
Here you see a little bit here you see the contradiction of energy efficiency. If you want to be energy efficient, you have to build larger installation. So if people say to me, DC is more efficient, I say no way. DC is totally not more efficient. But DC makes it possible to use as much as your own generated energy inside the installation. So DC is efficient from the point of energy consumption from the grid. But the installation itself, to handle energy neutral, you need to increase the power. And that's why the losses, the biggest disadvantage in this installation, my standby losses are high. And that makes actually it less efficient. But these high standby losses makes it possible to adapt the large PV array to consume all the energy from the PV to be power neutral through the grid.
Yeah.
And that is why I'm saying you need to come to sharing, because this installation is way overbuilt.
Yeah.
Because this normally should be done for 4 houses.
Yeah.
And here you see the few things. You see here the 3 loops. This is for the PCMs to control the energy temperature inside the floor to manage. I can do cooling, I can do heating. And this one is the fine adjustment. And this one is a very simple one, and nobody does this. You have here an energy recovery unit for the air. So normally you take the air from the outside and the air from the house you blow to the outside, and then you interchange this heat. So you get 21 degrees from the outside from the inside to outside, and then 10 degrees from the outside. You heat, and probably you meet 20 degrees, 19 degrees, and then you put the 19 degrees in your home. Now, I'm not sensitive, but my wife Jill, she's sensitive. So if you have 19 degrees air coming out of you feel
Uncomfortable?
Uncomfortable. So I said that, but we have to fix that. So I do preheating the air with 22 degrees. So so when I compensate with a small unit here to preheat, why should I bring the cold air into the room and then the room has to heat up the air?
Yes.
Why not do that up front? And if you do 22 degrees of air flowing, then you don't experience this this kind of thing. So I can do, in this case, I can do both. Then this is also important to explain. This is from Heliotherm. It's a super good unit. And what is interesting from this unit, this is for my hot water. But instead of normally in the Dutch, and I don't know how it's in other countries, but in the Netherlands, we store hot water with 60, 70, 80 degrees. And this is stupid, because we have cold air coming in, cold water coming in, and what is done here, and that is incredibly smart, the water is exchanged, the heat is exchanged from this tank to the cold water here. So you always have fresh water that you preheat, like a Dorfus heater. So this, and the nice thing about this is now, on the moment it is 42 degrees. And if you want to make 42 degrees from HVAC, that is doable. So I reach with a relatively high COP, close to 5 on the moment, close to 5 to make hot water. And this is important because mostly in the traditional systems, the hot water is done by resistive heating, that COP is 1. So we need 5 times more energy to heat. Now here you see the buffer. This is one of the discussions I still have. This I can bypass this buffer, but anyway. But this is the HVAC. And it's incredibly, how to say, the HVAC is too big. Way too big.
Why is it?
Because I measured now when it was minus 10 degrees, I needed 10 kilowatt hours electricity a day to keep my house 21 degrees with outside of minus 10 degrees.
Okay.
That's already super good. The COP is close to 8.5.
Okay. Yeah.
And that is super good because the point is I have a ground loop, so I have soil heating from take 10 degrees from the ground, and because it's from 10 degrees to 22 degrees, it's a very small step, and that's why you get this very high COP efficiency. But the interesting about this one is that you can run a little bit in higher power, because I can, when I close this loop and only run this loop, I can bring energy to the floor without affecting the temperature in the room. So that means when the sun shines, I can run the HVAC harder than it should be, and I can bring it to the floor, and then I don't need it run it at night, because then the whole night and everything, the energy can be redrawn from the PCMs itself. So it makes it in a very fast way to control. Again, it demonstrates that you get big installation to be energy efficient. And here you see the interlink converter is the battery converter, and the IT management. Here you see the solid state breakers. They are still expanding. I'm still working on this one. Here you see the batteries. And the batteries are built in a swimming pool. Okay, yeah. Because I have fire extension there. Yeah. This fire extension, if something goes wrong, I can enable to let the sink the batteries. And then I can, there's overflooding, I still need to connect it, but then it's overflooding and I can pump in, and I can cool the batteries to prevent the fire. Because the battery bank here is 114 kilowatt hour, and that's the reason I'm using maritime batteries, because I know this ecosystem quite well, but the maritime batteries are super interesting because they are IP66, 67 even, and if they are flooded, you can cool them and you can still recover them after flooding, and they are how to say, more stronger from the fire point of view. So I'm still using LFP batteries, and I purchased these through my sons because they're running this maritime electrical propulsion company, so I can to sponsor them a little bit. And this is the smallest size they had. So, and that's why the battery bank is 140 kilowatt hours. I must say the bank is not connected today because it does make sense in summer to have the batteries now today because I'm still net metering. But next year these will be connected because I'm still waiting for a few devices to connect them in this way to build. And here you see also the small mic controllers. This one is then emulating the MQTT broker and the management for the heat pump, the thermal system to manage the whole climate. And the HVAC, that's because I first connect because I moved in January. I don't want to experiment on DC with the HVAC in January because I also still need to live there.
Yeah.
So this is the next step later on. This HVAC will be converted to DC, and there I want to play around with the batteries and the droop control for HVACs because HVAC has a very bad effect on droop control. You need to manage them in a proper way. So I want to develop the algorithms how do you manage the droop and the HVAC in a smart way into the system. So that is the next step to go.
Yeah. Looking a bit at the questions, I think we cannot cover all of the questions right now because we have time issues slowly. And I believe you wanted to show a bit more around here, so to continue the tour. But there's one maybe a provocative question by Pepperine, who we met yesterday. Perhaps Harry's statement on energy efficiency is a bit of an apples and pears comparison. The high standby losses would also exist in a similarly IoT connected but AC connected
Of
house.
course, they will exist, but I can tell you my standby losses is 400 watts. So that means that is for 24/7. And that is already 11 to 12 kilowatt hours a day.
Yeah.
That's massive.
Yeah.
That is more than an average household consume on a yearly basis.
Yes.
So, but that is needed. What I say, these standby losses are there, and that's including everything. It's including the IT equipment. It's including the converters, the losses in the converters. But my PV installation is, I have 90 panels of 475 watt on the roof. So it is more than 40 kilowatt of peak power on the solar. And I have my converters on the roof. And maybe to explain a little bit why this standby losses is the issue, because this I want to utilize the energy as much as possible. I need bigger converters. And then I can manage the energy, go to the batteries and to do everything. So I can, the power of this installation is 40 kilowatt, and I need these 40 kilowatt to be energy neutral on a daily basis in January.
Yeah.
And that is the insane part. For the remaining 10 months a year, I don't need it. And that's why one of the steps I want to make, first of all, I want to get rid of the noise. So I want to have water-cooled converters for households. Because if you do water cooling, you can recuperate the heat to the HVAC. You can increase the COP again, a little bit. It's peanuts, but you have cooling properties anyway. And I want to make different capacity of converters when I don't need the full power, that I can switch back to smaller converters and have lower standby losses.
speaking of batteries, we have to switch to the table for just 2 minutes because we have to change the battery of the camera.
Okay.
It's down by 30%.
I think we have 10 minutes, so if there's a question relating to this area, I think we
We can
should...
ask them the question on the table, so maybe
Maybe we could
Is this
Yeah,
the
we can
power
be-
of
yeah.
the camera.
in parallel.
And by the way, the AC is then in the microgrid, so the AC is created. So AC is an option.
Yeah.
It's powered from the inverter. So this is running in an islandable system.
And this is for the kitchen, right?
For the kitchen, yes.
Yeah.
I have 22 kilowatt of AC power, just that I don't need it. But in the case of an exotic meal, then
Yeah.
you need it.
Okay. Okay.
And one thing to tell about the solar system is that
We're here now.
one thing to tell about the solar system is that I oversized the PV array, and I've calculated because the PV is optimized when the sun doesn't shine. So mostly people optimizing the solar system when the sun shines, because you want to recuperate as much as possible of energy. But the point is, when the sun shines, the energy is valueless.
Yes.
The energy has value whether the sun doesn't shine. So you need to optimize your solar array. So I put in all 4 directions, north, east, south, and I put the PV panels quite flat, 10 degrees.
Why is that?
And normally for winter, it's super good to put them at 45 degrees.
Yeah.
But if you increase the area and as much as possible, because you put 45 degrees, you create shade to the other panels. So if you put them at 10 degrees, you don't create shade. And mostly in the Netherlands, the sun doesn't shine. Now today it's shining.
Yeah.
But when there is cloudy weather, the light is coming from all the directions. So it's better to put them flat, because then you have more exposed surface to the clouds. And then you have more energy that you can mine during cloudy weather. So this installation already start to produce, like today, for example, at 6 o'clock, I already run a couple of kilowatts.
Okay. Yeah.
And
that's quite a lot.
a lot.
Yeah.
And on the rest of the day, I curtail my installation because I don't need the power. So I have plenty. But in the winter, I was able to produce, in January, I was able to produce 30 kilowatt in average per day. And my energy consumption is 30 kilowatts a day in the winter. So I run in January, I run already energy neutral based on the PV array. And I only had in February, I had a little bit an issue because of a few days of snow.
Okay.
That was, then I draw power from the grid because my battery system is not active yet. So that, but otherwise my battery system will overcome that. And the PCMs in the floor, they can store also for a couple of days. So I don't need to run my HVAC when all the time. So I can be shifting around to make things efficient, to be as much as possible from the renewable side.
Okay, thanks. Then there is a technical question here from Ricardo. Why not using high power converter with flat efficiency like roofs are? Because then you can be the efficiency load independent. Otherwise, using different size of converter, you will get issue with load step not.
No, but that is what Current West is menacing. The load step doesn't exist.
Okay.
So the load step can easily be done by the droop. Droop control, and we have rules in Current West that to prevent that one, so you can run on smaller converters without the issues of load step. So you don't have this passive on and off effects, because then you have an issue, because then you need to have a kind of inertia and you need big capacity of the converter. And technically, I'm using now water wall converters, and I must say I'm quite happy with them. They're working quite good.
Okay.
But except for the noise, because they are industrial converters for normally for EV charging purpose. But it makes more sense to have water-cooled versions in small power, like a Brusa from Ricardo. I think that the Brusa converters are also very beautiful because they are in it mostly water-cooled structures, and I definitely. But we need to have a droop response from the converter. So with the water wall, I could manage the droop. But for the converters, that is one of the requirements, because the load steps, the dynamics should be done by the voltage, because otherwise you come back to the control schemes. You need a digital layer to manage the energy flow, and again, then you need to have a centralized controller, and you need to manage everything. So it makes a lot of sense to have the fast response always autonomous by the equipment of the power dynamics, and then with the demand control to change the requirement and to change the goals, so that the devices can better optimize in the fine tuning for the longer term planning. So the long term, it's demand sending, and in the fast term, you need to have the physical layer that manages the power.
Yeah, thanks again. I hope that answers your question, Ricardo. Then we're back again on the camera, so we can move around again.
Yeah, I don't know what right time, because I think I can still talk to 5 o'clock. So that's
I don't know. Everything that you feel is relevant or necessary to hear.
I think for me, what I think we need to, what I want to bring to the topic is that we need to change regulation for houses. Because I try to inspire the ecosystem that things can be done differently. And there are many more things to tell, like the air system from the kitchen to take out the air. How the air is circulating in this house, it's done because we have the kitchen in the living space. And if you make an exotic meal, then you always have the smell. But this one is optimized in a way that, and that was not neutral. From the ecosystem, because they come with different proposals, and they only looking what is easy for them to install, but they don't look to the performance of the installation. They're only looking to the requirement from the government. What is the minimal requirement to install, and that they manage. But here we push on the wall, we overpressurize the wall, and then we push the air through to the kitchen, and in here we on top of the kitchen we have the air inlet. And we make in the core, so behind the kitchen is the toilet, here behind is the bathroom, and that we have a small core where we take all the air, and the air from the other rooms are always pushing in from the outside and to take. And so if you use the ventilation from the cooking, the van is put outside the kitchen because they are normally incredibly noisy, and I don't like noise. So that's why I have the fan outside, and then taking. It's more efficient to do that because taking air in the end of the pipe to take out has a more laminarity flow. You can transform more cubic meters instead of blowing in the tube that has a lot of turbulent flow and that has more pressure, so you get less cubic meters. So you have a better better intake from this one. And that again, this is also now managed by the circulation, because the van is two fans, so I rebalance. Otherwise, you start to complete unbalance the air system, because this one can draw roughly 700 cubic meter of air outside. So that means then you get issues with the ventilation unit. And this is the cabling is done also on 350 to here, so the cable is already there. And I'm really want to fight with the Miles and the Boras and the people to get them on board and to make this equipment, because definitely all equipment can be a DC. And it's a big use case for kitchen appliances, because they are the power inefficient devices we have. They need high power versus energy. And it makes more sense to have a modulated oven, for example, because now the oven is 2 kilowatt on off. Why not modulating? So you heat, you go back, and you can modulate roughly with 200 watt to compensate the losses, and you have a 200 watt connection. And that means with the induction stove the same. You can do far more smarter to reduce the total of power, because now I need 22 kilowatt for this kitchen. And but the energy is peanuts, and that's why I'm saying if you do that on DC, probably you can have 5 kilowatt of power on a DC. And if you put a battery inside here, then you can have a 200 watt converter to connect. You only need you make a USB-C, for example, to do the cooking, because you have 24 hours to charge your kitchen for the meal. So it doesn't matter anymore. So,
but what do you think needs to happen for the manufacturers to change their mindset regarding these issues?
Looking to business case that creates value for the system.
Okay, yeah.
Because that is the part that's missing. Now they create only the value to compete, and the stupidity is that all these manufacturers try to make the same to compete. So you want to make apples? No, you need to make passion fruit. You need to make something else. And if you can make something else, and just a stupid example, most houses in the Netherlands are gas, and you want to renovate your kitchen, you want to have induction stove, you want to get rid of the gas. You buy induction stove of €1,000. They are competing as hell on these ones. But then you need to go to the installer, because they need to upgrade the panel. You pay 5, 6, 7,000 euro to upgrade the AC panel to connect the induction stove from €1,000. So why not make induction stove of €2,000 with the battery inside, and you don't need to upgrade the panel? So if you bring more functionality, and you bring more smartness to your product, you have a better business case. But then you start supporting the system. So you should not compete to each other. You should differentiate from each other, and you should help the system, and then also bring value to the user in that case. Because you can create new business cases. So, and that is why I want to use Miele and Bora to be smart and to build something beautiful on DC, and within the integration to come with a USB-C powered induction stove, for example. You can bring the data, you can bring all these kind of things physically, or even with power over Ethernet you can do that. With a 90 watt, you can already bring enough power to every plate. And then you have this battery contributing again. So you come more to, this is a different way of thinking. And this is really what I miss in the ecosystem, because they always go in the same direction and to be cheap as possible and to make business. And that is, if I was, I'm an entrepreneur. And I've always learned, entrepreneurs are failed criminals, and you always have to look to the opportunities. That is the asset of a criminal. So, and that is the asset of an entrepreneur. You should look to these kind of sweet spots where you can differentiate. And that I see is the big organizations, they come to the common behavior, and they all act as me too. And that is stupid.
It's a form of incremental innovation then, and I could imagine that for a manufacturer like Miele it would be a higher form of risk taking to go into another direction.
But that is entrepreneurship. Entrepreneurship is risk, and entrepreneurship is then taking risk but managing risk. And that is, and if you don't take risk, then you do nothing. Then you stay forever in the same state.
Yeah, but what would you think would such manufacturers actually need to go into that direction? Is it demonstrator sites?
They need demonstrators, but they need to be understand that they play a major role into the system, and they don't realize that one. They now assume that like the kitchen is standardized. An induction stove, 1700 watt, 2.5 kilowatt, 7 kilowatt, whatever kind of things. They standardize. They have these classes. Even on standardization, they make rules for that one that everybody can expect the same. And the world is ending there. But what I say, now I have to make 22 kilowatt AC to run my kitchen, so I have to buy a big inverter to feed my kitchen, while I could have a small converter. And if the kitchen is twice as expensive, like from €1,000 to €2,000 or whatever, I don't care. It's a business case. So, and that I don't understand. So if you understand the value that you can bring to the system, then you are in heaven from the business perspective, because you can bring high value, you can have a high price, you can increase your turnover, and you can make happy customers. So it's very simple.
But also, I think the customers need to understand that there is a certain form of value behind that, and that there may be a technical alternative that could prevent these higher costs and so on. And this is what has to be seen then by the manufacturers. I mean, standardization, you have talked about it a few minutes, is said to be very important. There's a new incoming question. Can you weigh USB-C PoE powered DC loads against loads capable of connecting directly to 350 volt DC with support for droop control?
Yes.
For example, for kitchen appliances, high power, low energy, and inherent capability to store heat, wouldn't it make sense to go for droop control based demand response?
Yes, I totally agree. And that's what we do in Current West. So in Current West, we make this whole set of rules how to connect high power devices to a 350 volt system, how to react to the droop, what is the playground for equipment to work on the voltage level, to automatically take the fast response natively on the system. And that's what Current West is about. So in Current West we have these rules to connect devices, even with plug sockets, to have arc-free connection, to have arc-free disconnection on these plugs of sockets. Based on the requirement, the specifications, what you need to fulfill inside equipment. So all these rules are there, and that's why I really want to call. Please come to Current West, because there is this huge, happy community that is working on this new future system, where this interoperability, this interconnectability of devices is working in a more high available environment with a higher value for manufacturers to build these products, and that is for buildings, for all these kind of things, for whatever, for industry, what you want to do. But you have to be part of these communities. Don't try to build an ecosystem yourself that is closed. You should make an ecosystem that's open and interoperable, and then compete on the value you create with your equipment, not on price. That is my recommendation for manufacturers. And then I can tell you, in this environment you have a very happy business perspective and a very inspirable business perspective.
Okay, yeah, thanks very much. Should we now then return to the table for the discussion? Okay, so then we will prepare the setup. Just audience, please give us 1 or 2 minutes to be ready again at the table.
Your battery is still okay? I can plug it in otherwise. And this is just like the USB-C. I always like this example because USB-C is really an interoperable socket globally. And that's why I think we have so many more USB-C sockets already available of the same type on the planet. So it is really a way to standardize in a proper way.
Regarding this USB-C sockets, I would have a question actually. Regarding the updatability of this setup. So USB-C is the standard right now, but what about like in 20 years? Will there be
then it's
USB?
only replacing this part, and this is a very small part. So the converter is really, how to say, if you this is just normally space where normally an AC socket is. So the diameter is less than roughly 4 centimeter, 1.5 centimeter depth. That is where the 100 watt power is connected, and that makes it possible to easily replace. Because if you integrate everything together, like from Anker or from all these manufacturers who make these 500 watt blocks, if things change, you have to throw everything away. Now only you need to change the endpoints, the connection. So if USB-D is coming, USB-E or whatever kind of things, okay, you only need to replace, because the framework is plenty. And of course,
it's much easier.
What I really like that I will see in DC happening is that we get high power USB-C. That means we get a different type of socket. Maybe that is the USB-D that is capable to do 3, 4, 5, 6 kilowatt with the same structure, data and power integrated, but then maybe a little bit bigger plug instead of the half centimeter, make it whatever 3 centimeters, and then have. But the same principle. I think that concept is super good scalable for DC sockets, and this is how you can make future connectivity in the same pace as the value that USB-Cs bring. Because there's one also I forgot to mention, but there's incredibly important functionality of USB-C. USB-C is inherited in DC microgrid because it doesn't matter anymore how you connect it. So that means you can discharge your laptop on the USB-C socket, and you can distribute the distributed power, and you can build a meshed architecture in the 48 volt structure. So you are in office space and you have 100 laptops on the floor, and there is an outage. Okay, you can still power your monitors, you can still power some lights, you can still run in a kind of distributed system, and that's why the USB-C socket is a super nice socket, because it enables bidirectionality by default. And that's what we're missing, for example, with pluggable batteries in AC. We make a big mess with the balcony PV inverters. We start using AC sockets to be bidirectional. That's scary. And yeah, that makes a lot of sense on that part.
Then maybe fitting to that discussion, there's a general question that was asked at 10:54 by Miao-Xing Wang. Can your house run only on DC when the AC grid is down?
Yes.
Yes, it can. Okay, it is
yes.
high-landable.
AC, what I say, AC is an option.
Yeah, okay.
It's me, the grid is nothing else than an energy source in the case of backup. Because technically, not today, but the installation is designed that I can run technically 365 days off grid. I don't need the grid for my use case, including mobility, including heating, including cooking, everything. So, but if there is a horrible winter, then I need roughly, I can live with 20 kilowatt, I can comfortably live a day. So 20 kilowatt hours. That means I can roughly connect with 600-700 watt to the grid. In the case, I can make a very weak connection to be complete independent of the system. Not that I should stimulate that we should independent on the system. For sure, we need to support. We need to be connected. But then the question comes, and that is the interesting part, is I can massively contribute to the society with this house. And that I should do, because on the other side of the street is social housing. And it looks very horrible if you live on the other side of the street. You live in a beautiful house still there. Everything is nice. But then you see these asocial guys with these big electric cars, with this big house, with everything very posh, very capital looking. And normally in the old days we had always a barbecue here on the street. If I don't take action now, I will not be invited on the barbecue because I'm this asocial person. So I want to be invited on the barbecue because you want to live in an environment where you have happiness with your neighbors. And now I've polarized it. So I screw up my relationship with the neighbors. So it is so more important that I can contribute my neighborhood because that business case for me, the contribution is so much value that you create because I'm really invited in the barbecue. And that is important. And because I can contribute. And that is why the second grid, that's why this social community, this physical layer is incredibly important. And if I can bring benefit to the society in that way, you build a community back and then you get back a happy environment.
This is really interesting because in Germany I have the feeling that these forms of social conflicts are not yet on the reflection level in a way. So they are subliming, they're not really there. So which arguments are put on the table by your neighbors if they see your electric car and this house installation and all of that? So what do people tell you?
People feel jealous. They feel that is the worst thing, and I have it already experienced because during the renovation I was living somewhere else, and I have to do public charging, and I parked my Porsche in the other area, and one day I got a note on my car: "You don't belong here." And because I was parking in the other area and I was utilizing their parking space, and because lack of charges, so people get fucked up by this behavior, particularly when and the same is here because the people here, how to say, I'm not a horrible person, put it this way. But you feel already the tension, because I know in this area there are a few homes that get subsidized by the local government because they're in energy poverty. And it feels very, very strange if you have lived in a house, you have too much of energy. It feels really like, okay, there's hunger in the world, and we're living in the neighborhood where there is hunger, and my waste bin is overflowing with leftovers of food. That feels human way so wrong. And I have very strongly this feeling the same way now, that the people there in the other side of the street have this, it doesn't fit right. It is really, a showcase to look horrible, and people will be angry. That's why I always saying the energy transition with the current vision today is a transition of disappointments. And the energy transition itself is so beautiful, but the way how it's executed is disappointment on disappointment. And I take the Netherlands as a big example, because we are super good in running problems fast. But this will be an example for the rest of Europe. In Germany, you will get the same issues. Yes. You will get the same stress. You get the same topics on these kind of things. When people have big houses, they have low energy cost. When people have small houses, they have high energy cost. And that doesn't make sense. That is wrong.
Yeah. Yeah, and what has to happen to better utilize this situation so that you would be able to share with your neighbors a physical cable, as we discussed before. So, but in terms of regulation and installation, so
regulation, what we need to share now, there is a few laws. Technically, there is in the law, there is room. In the laws, there is room. Yeah. Only the issue is at the regulator for the grid operators. The grid codes are missing. There is, for example, not the possibility to have a second connection to your household, to the community. Just to take an example, and there is no measure there how you deal with that one. There is no rules, because you need to have a lot of rules if you build this community, because you will be connected to two systems. You will connect to the public system, and you will be connected to the local system. Because not all equipment will be powered from the local system. And so that part is missing. But you need also a little bit go beyond that one, because just take the HVAC as an example. I drill 3 loops of 60 meters into the ground for my source of my HVAC. Why didn't I put 4? And I said to my neighbors, let's share the cost. So let's share the source. So why not put 10 loops and share it to the community? Because then the cost is horrible high of these loops. So, but if you can share it with 60 houses, the cost is peanuts. And then you can use water HVACs instead of air water. And then on the energy point of view, the difference between air water and water is not so much differences. But if you look to the peak power in January between water and versus air water, there's a huge difference. So the effect to the system, so the grid operators should stimulate HVAC with water source, because they have the lowest power requirement. Because water HVAC can easily, like in this structure, can run with a COP higher than 8, while in the winter when minus 10 degrees, while the air water system runs then probably with a COP of 1.5, 1.6, 1.7, and that means if you need 10 kilowatt of thermal heat, okay, then you need 5-6 kilowatt from the grid. And if all houses does the same, then it has a huge electrical impact on the grid, only for a few days. And then the grid needs to be expanded to overcome the supply security for a few days a year. And that is a very inefficient investment. You should be power efficient to overcome that part. You shall be power efficient. So it should be the rule. Energy efficiency, we have to scrap from our vocabulary, and we have to replace it by power efficiency, because power efficiency brings more value than energy efficiency.
Okay, thanks for answering this question. There has been a question at 10:57, which I find very interesting, and the question is about vehicle to grid or more vehicle to home here. Are you using bidirectional V2G with your EV car?
I wish I could do.
Yeah, okay.
But the car manufacturer doesn't allow it yet.
Okay.
And I understand the reason why they don't allow it. That's understandable. And there are a lot of drawbacks on vehicle to grid. But if you do vehicle to home, that you should do on DC, because I see development from some car manufacturers, they call V2G on AC. Again, that is how to screw up the system even more, is to introduce V2G from the grid. So the cars will definitely not contribute to the system if they enable on AC. But on the DC it makes a lot of sense, because then you can build in the community level, you can build the V2G, you can share the batteries, you can integrate optimal PV with drop control, so that the EV charge automatically charged by the shared solar installation, and it makes a better use case and a more efficient use case. But V2G on AC, from the converter perspective, okay, it's possible, doable, but more complex, more noisy, in a certain range, but less efficient if you want to use it in a full range to operate. But from the system point of view, it's horrible. And again, we start to, and that is why the energy transition is a chain of disappointment, because this will be the next disappointment into the system when we enabling AC V2G, and then people, again, the subscription cost will be higher. The grid operator need to make more cost to deal with this type of equipment. Subscription cost will increase, and everybody again will say, yeah, energy transition, yeah, it costs money. And it should not, it can be done much smarter, and it could be more cost effective, and it could be at lower cost and in a more fair way that everybody's benefit from it. So that's why I always hammering on the point, a system approach, and don't be selfish on one component in the system, and try to avoid angry people, because angry people are the most expensive objects in the system. So the business case is always good if you create fairness and happiness.
Yeah. Thanks very much also for an answer to this question. Going to a different arena in a way, here is a question that I find personally very interesting, asked by Wilhelmina at 11:39. How far have developments progressed in the line? Electricity generation via solar parks, wind turbines, direct current transmission to business parks, residential areas used by consumers.
Not yet.
Not yet.
It's all sheetware.
Okay.
I love to make hardware of it, but today it's still on sheetware, and it has to do simply with regulation, because there are no grid codes yet for DC. There's no possibility. There are no metering codes for DC. The connection codes are missing. All these requirements are still missing. So we need, technically everything is possible. The products are available to do. The knowledge start to increase into the ecosystem, but we need to influence the regulators, and normally the grid operators need to communicate to the regulators to change the codes. So normally the regulator don't make the codes. The grid operator makes the codes, and they bring it to the regulators, and the regulators look if it's a fair code. So and then the political layer should make incentives to the grid operator to be in this way around. And that's what we try very hard to influence. We're lucky in the Netherlands. We have a person who is visiting our company, our president, so he knows what we're doing on DC, and he was super interested in that part, and I hope he not forget it. But these kind of things are, important, that we need to make policy on the political level, and that the grid operators can modify, and that the authorization from a market, the consumer, or the ICM, or the regulators can manage to see if these codes are correctly.
So the pathway is more bottom up, or is it top down to get a better understanding? Because you said, well, the grid operators then go approach the regulator if they have a problem with something or whatever. So you need to steer this development via the grid operators or via the policy, because this would be the other pathway. Both. Okay.
You need to do. You need to make awareness in the end users of the ordinary households. So they need to put questions they should discuss. You need to make awareness about the local municipalities, because they are responsible for the planning on the street for households, house building. And you need to make awareness at the grid operator. The good thing is that the two big grid operators in the Netherlands, from the three, we have now two. They are really serious looking to the second grid approach because they run out of options in AC. And because the 50,000 transformers to install goes 10 times slower than they expected.
Okay.
So the grid expansion really feels as a mission impossible. And now that big regions like, for example, Utrecht region is completely locked down. That means even a household who want to upgrade from a single phase 40 amp to 3 phase 25 amp, he will not get the upgrade.
Oh wow.
So that even on a household level, there's complete block for the next 5 to 10 years. So zero activity, no installations of chargers, public chargers, not possible in that area in the heart of the Netherlands. And that area is expanding incredibly fast. It will expand to now Amsterdam will come to the same, Rotterdam will go to the same, The Hague will go to the same, and the grid operators they need a lot of space because that is what they misestimated. Particularly in cities, you cannot easily upgrade a power station because you have to bring down buildings because you need more space. So you have to increase the power density in this space. And then technically, so you have two use cases for DC. You have a technical use case. That the technical use case is mostly on the medium voltage part, where you can support the grid more efficient. And you have a social use case on the lower voltage part, where you build communities. And these two use cases are incredibly valuable. So they have a different driver and different audience, but they are both important to continue. And that is what now the grid operators in the Netherlands are examining. So there is a team really looking into these aspects now, and we have regularly discussion with them about the technical topics, how to do, and the consequences. And we have now, and this is one of the projects we try to fire in this neighborhood, because we have green light from the local municipality to support. We have green light from the social house owner. It's a single owner to be working on this one, because these houses need to be renovated to be fulfilling the energy transition. And I try to make noise here in the environment that the people, in the end of the day, like to go to this adventure, because also you need to stimulate the users.
Yes.
And so there's a multi-level. You have to play the game, and you need, because it's a system. And in the system, everybody is there, and it's a very wide approach.
Yeah. Thanks very much also for this answer. We are coming to an end slowly. Thank you for the remarks also on the energy communities in Sweden and elsewhere. We will have them documented. But as a closing question, I would take this one here from Andres regarding the payback period. Given the cost is still the main decision driver in most households, what about the payback period?
I forgot to tell that one. It's a very good one.
Okay.
Of course, to be honest, this installation you will never earn back. To be honest, that's clear. But I do all these experiments and I do all these kind of things. But if you take to the general approach, what today we do with the payback time, we look to the energy cost, and then we start to look how much energy can we save, and then on the saving we make our earn back. That's again a very, a non-entrepreneurial spirit of making money. You have to look very simply, how much money do you spend on energy, how much you can invest to bring that to zero. So, and if you bring that, for example, to a mortgage or to your investment, and you say, I want to have a return of investment because you're a B person. Okay, I want to have my return of investment. Okay, I want to earn it back in 6 years or 7 years. Okay, accumulate all your energy cost, convert it to a loan with interest, see how much you can invest, and then when you pay back your loan, you have zero cost after it. And that you should do. And I've done this in this case because I was roughly on a yearly base in a traditional way with gas, electricity and diesel. I was consuming roughly 12,000 euros a year of energy. So if you start to see, okay, how much money did you can go to the bank and ask a mortgage, and you pay back 12,000 euros a year, No, you can easily invest 60,000, 70,000, 80 or 100,000 euros to invest to bring down your energy to zero. And with these numbers of money, you can build big installations. But what I say, it's not good to do that on every household on itself. If you can do that in a common way with your neighbors, you need a fraction of that money.
Yeah.
So that means the question should be reversed. Your cost will be higher with the existing solution than moving to a new solution, because it's a negative. The existing solution is negative business case by default, because you see it now with these horrible things like in Hormuz, all these angry people shut down things. You get so much nerves. You feel so dependent. You feel so vulnerable because of this dependency and because of this rising of the prices. You see, and if you can avoid that one by investment and bring it to capex instead of opex, and that is why the reason also. And if you look really to the philosophy of this in a higher level, if you look to the market model from the energy market, it's even wrong in that case. Because we have an OPEX-driven system from the energy. We introduced a CAPEX energy structure on top of that one. And if you have a market that is based on OPEX and based on CAPEX on the same market, then you have contradiction. And that doesn't work. So you have to split. That's one of the reasons why you need to have the second grid, because you have to split CAPEX to keep it in the CAPEX environment. So the second grid, the DC system, is a CAPEX-driven system, while the AC system is an OPEX-driven system, and you need to split them. And if you split them, then it leads to lower volatility in the market, and lower volatility leads to better pricing. The more volatility you have on energy, the more expensive the energy will be. So the more renewables we add to the electrical system, the higher the energy cost will become. So this in the opposite, because they biting each other because of the CAPEX model versus the OPEX model.
Okay, thanks very much. I hope this answers the question for now. I see a couple of different questions here. Maybe a couple of them, I believe, is an inspiration for bilateral contacts here. What people write, you have to have a look at the comments, Harry, after this meeting.
Okay.
We can do that. Just as we have 3 minutes on the clock right now, just to give an outlook, we plan to do another deep dive with another DC home project, which is driven by Wolfgang here, sitting next to me. So just to give you a short outlook, the next session will also be an online session. Unfortunately, we cannot do that on site, I believe.
No, there's nothing at site.
Yeah,
at the
there's
moment,
nothing
so
yet
we'll
at the
start
moment.
This year.
So we will only present the concept online, but could you just spend 1 or 2 minutes to say a few words about this concept? Yeah.
Yeah, so in principle it's also bungalow, like Harry's approach. It will be a new build, so not renovation. So that means it could be a little bit different approach, because you are completely flexible to do the installation. For sure the core is planned to be in DC, same, and also AC will be a subgrid to the DC solution. It's also intended to take the learning from this building to be implemented in this new building then as well. It's also looking at the complete approach of the building. So not only on the DC distribution and on the advantages of DC distribution, but also then the integration into a smart infrastructure, the complete building itself. So that will be a little bit different approach. So it's intended to reduce the energy, and especially the energy needs in wintertime, to build it in a passive house environment, which then has the capability to reduce the technical installation on the winter time for heating. So that makes it a little bit simpler. So you move to a little bit more insulation, but you reduce massive in the outlook, the technical investment you have to do. As it would be also a demonstrator, would be open to the community. The intention is also to push further the DC solutions. And also it's important to include the heat in a clever way into the house, how to do this, to also do it more optimized. Also looking a little bit on the total cost of the capex of the house, because to get it feasible for more people to move into a house with a high efficiency, with no energy need anymore. So that's roughly the target.
And what is super interesting, I want to comment on your case because I have a renovation project and I'm a family A. How to say I take the extreme approach and you take the lean approach. And I think that is the passive building approach is more lean approach.
Yeah.
And
so
that
it will be partly lean. So it should be in the outlook. The intention is to design and build a house that it could be scalable, affordable in the future, but it would be in this demonstration case the same from the technical side, or it will have more energy production than needed. So it will also go to close to 40 kilowatt peak PV, which means it's enough for 4 or 5 buildings. So the intention is not in this first building to get really down the cost from the technical side, but even having more technical installation, doing the measurements, and then afterwards making a proposal to, I would say, low needed technical installation for operation in a grid connection, as I said, not autark, no, but
please get closer to the microphone.
Yeah, to get it close to the future possibility to own houses also for less.
Yeah, and I think in the end of the day, everybody lives in a house, so it is a use case for everybody.
Yes,
if you are a CEO, if you're a big company, you still live in a house, so it's important.
Yeah. So that is one thing we can have a look a little bit deeper next time. And I think the other topic is that this is a kind of network. It's an open network. That means also open for the designing of the calls. So if there are some topics for deep dive in the community, I think that's also good. If you share this, then we can also take your interest into this calls and see that we can have a deep dive on your interesting points and see maybe that also we can get some experts for the specific topics then into the calls.
Okay.
Yeah. Then that's it. Thank you for your participation and your interesting questions. Thank you, Harry, for showing us around here. I think it has been a lovely experience for everyone.
Yeah, it's a lot of information, but I'm also very grateful that I get this opportunity to talk and to share, because this is not so easy to do, to bring it to public, because I have many people visiting, but they're small groups.
Yes,
and, but I need to spread, and it is incredibly helpful and powerful, and I hope the recording will be number one, go viral in the YouTube area.
Yeah. Let's see. Okay,
no,
but
also, I would say thank you. It's really good, and I think it's important that we more push this kind of networking in a broader community, and that we push these examples that we have. So that's very important.
Yeah. With that being said, we will be sending around the calendar invitation for the next appointment. We have to see when to do the deep dive together with Wolfgang, and we were very happy to see so many of you here. And then have a nice sunny weekend, and see you next time.
Okay.
Yeah. Good weekend.
Bye.
Bye.
Bye. Bye. Bye. Bye. Bye.